Now in this video we're going to look at to develop the Excel sheet. As you know, this process is very interactive process. I done many times, then I get this conclusion on the background to represent. Sometimes it get very tedious. So now to do this one, I think the Excel sheet would help that interactive process. Let's start with this one where we assume dn equal to 100. Let's work it out. Dn equal to 100. So you can open the Excel sheet that are shown here. So you can see this Excel sheet here. Let me put this dn equal to, let's put this dn, and we use this one 100, right? So we use this 100 dn. So that is the first steps that we done it. Now second steps, let's say this is your input. Let's put this one in the blue. Second steps, what we done the calculation of this compression strain. So that is the equations here that I'm just going to put it there. So let me put that, let's say ESC was equal to 0.003 bracket dn minus 74 divided by dn. Okay, so these equations is just these equations here. Now once you done this, you get this 0.0078. let's check it out whether it's give me this answer. Yep, 0.000078. so that is right. Now let's calculate this stress value. Stress sigma s is just this strain times this Young modulus. So let's say let's put s as a sigma, sc equal to that strain times by 200,000. so let's put 200,000. so 156, let's check, we get 156 there. Yep, 156 megapascals. If you want to put the unit, we can put the unit here as well. The next steps was here we calculated this force in the top steel. So let's say cs, so let's put c as force in the steel equal to this stress times by the area 1200. So that is 187 200. so that's 187 200. let's divide by 1000 to get it into kilonewton. So let's do the divided by 1000 to get it into the kilonewton. So let's say this is in kilonewtons. Let's put this tax in the rate because we might going to use that one over and over. Then what was the next steps? The next step was to calculate the strain in the bottom steel. So we have this equation 0.03 526 minus dn over dn. So let's put EST equal to was 0.003 times by 526, take away dn divided by dn. So that gives me 0.01278. let's check. So we calculated that 0.0128. so that is okay. Now we know the stress is 500 megapascals. So like this, let's copy this one, but we have this, let's say st stress is 500 megapascals. Let's put this 500 megapascals. So the force ct was equal to that stress times by the area, and let's divide by 1000 to get it in the kilonewtons. So that is in the kilonewtons. Let's put this one, all the forces in the rate, and let's check it out whether we got 600 kilonewtons was here. 600 kilonewtons. I just have this force times 1200, that's value. So this force times 1200, that's these values. Now force in the concrete, we can just straight away use this 10996.8. Force in the concrete cc is equal to let's say 10996.8 times dn divide by 1000 to get it into the kilonewtons. So that is in kilonewtons. So that's third one. Okay, so let's check it out. So we have this 1100, that's perfect. Let's check it out. So that is 1100 kilonewton, that's fine. Now finally we need to sum them up. Then if you just sum them up, all the red one, this kilonewton cc plus cs minus ct, right? That's what we done, right? So we are going to sum them all up. CC plus CS minus CT, we done that. So it should be 687 around. So if I done that, yep, 687 around. So that's perfect. So that is kilonewtons. Let's put this kilonewtons. Now after that, the process is simple. What you can do, you can just copy these whole things, Control C, or you can just copy here and just leave one columns down here and just put Control V, and you just change the value. Change the value meaning you have 74, like we use 74 here, we use 74 here. So let's change this 74 here. 74, it gives me 213. Let's check it out. It's when you have 74 you get 214. Yeah, almost close, right? So that's perfect. So that is good. Now the next one that we use was 60. Next one we use 60. So let's copy that and let's say use 60. So now we can use any value. Let's say I use 60, then it gives me this value. Let's use 62, it gives me minus 57. Let's use 63, it gives me 32. Let's use 64, it gives me minus 80.7. Let's keep increasing. 64.1, that's good. 64.2, I'm trying to make it this one 0. 64.3 minus 1.5, 64.4, it's almost 0 now, right? So if I go to 64.5, it's just increased this one. So 64.4 is almost 0. So let's check it out and compare against your one. So against our calculation, 64.8, almost close, right? So that is the iterative process that will help you in calculating this kind of iterative process. So you can say that dn equal to 64. You can change any value here. You can change this one to 80 and it will give you this value. If you change to this one 60, it will give you this value. So I think this is that's how the structural engineer works. They have a many Excel sheet to work through these manual calculations, because sometimes you are repeatedly use these equations. It is better to develop this Excel sheet. I hope it's helped. Thank you.